Okay, I just started recording.
Okay.
Okay, from here it looks okay.
Yeah.
Maybe it's too tight, but I'm not sure. But it looks okay.
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 And I did take a multimeter to it, and it's connected, like the wire is intact.
Okay. So, you have this device is a similar one. I think you have this model.
Yes. I think we have the same.
Okay, great. And you also have the dry valve or not?
Sorry?
Do you have a heating device, temperature device?
Oh, no.
Okay.
Just this.
Okay. Okay, fine. It's the same. So I have a heating device, but I don't want to confuse you. So I will turn it off. So it will not detect it from the software.
Okay.
I'm not 100% sure because the engineer that I was able to see which version of the software you have, but probably you have one of the latest software versions, but we can easily see from the number. You can see if you go to the about.
Yeah. Copyright 2017 version 2.0.7618.16993.
Okay, now I don't remember if you send me some data I can possibly see it, or if you send me a screenshot, I can make sure.
Okay, sorry.
It's okay. If you send me later a screenshot
of
this page, I can make sure that we will have the last version.
All right.
So I'm Sophia, and first of all, I would like to ask what you are measuring. If you are measuring any strange fluids, I think I asked you before, but I want to make sure.
No, it's just tap water.
Just tap water. Do you know if it's like very the salt amount of the minerals in the water is very high?
I'm sorry, can you say that again?
Do you know if the salts or any minerals, the concentration in the tap water, if it's high?
I don't believe so, but I don't know.
Okay. Did you try any distilled water from another lab, maybe instead of the tap water?
Sure, I can go try that.
Because it will show you a difference if there's a problem or not. First of all,
but the numbers are so off. Like it's telling us the thermal conductivity of water is like 0.1 watts per meter Kelvin.
Yeah, probably there is an issue with the calibration or something. If you take some measurement and later on you can send me the XML file, I can see some parameters they are off. I will share my screen with the software so we can do in parallel the same things and make sure that everything is working fine. So, okay, let me close that because I have opened a new one.
Actually, you know what? I'm going to join the meeting also from the computer that actually has the software installed. I think that might make things easier because then I can share the screen.
Yeah, sure.
Directly. But okay, yes, your window looks like my window.
Okay, perfect. So for sure you can see the device, okay, where the port where the device is connected.
Right. Yes.
So as a first step, you said that every time you press detect power, you receive something different, right?
Right.
Okay, I will press the detect power and see. Usually it's close to 300 for the water. The only case that you think that's why I asked you if the minerals on your tap water are having a very high concentration, because in that case you can get maybe weird results. So in my case, I have probably, you said someone else was using the device before you, or no one?
Yes. So another professor
Okay.
used this previously, and this is my undergraduate student who's been working with me.
Right. So I don't know what they were using before, how it was working for them. But yeah, really, I don't know. If you try with even the tap water you are having, what is about the power you are getting? If you try to take it.
Well, it changes. So the default setting is 200, and sometimes when we say detect power, it's close to 200, maybe like 220, 230. But then other times we'll say detect power and it'll read as 9. It's very inconsistent. Yeah.
Okay. In that case, either it's like the salt and any minerals inside the water are having very high concentration, or there is an issue with the sensor. So because usually even like if you need the most of the times for water, any water, it should be higher than 200.
Okay.
And
Um,
so in that case,
DI water. Fill that with DI. And come back. Okay, great. Yeah. Okay. Iris is going to go fill that with deionized water so that I can
okay.
mix it again.
Okay, great. Okay, for now, I will continue. I will show you. And then we can do the same with your device. So
Okay,
you
great.
know the procedure. I press save. Normally you need to wait a few minutes. It's very important to have your sensor somewhere that also the temperature of the fluid will be stable. For example, if you have your bucket close to a heating source or somewhere that there is like the air condition, so there is a movement of the air, so change of the temperature. Yes, this could result change of the thermoconductivity of the fluid, because actually you have a natural convection, so you will not be able to have accurate thermoconductivity measurements. So if you press the plus, it just start running a measurement. We can try to later something manually in case something happened and the values were very off. But you can see here the sensor was not calibrated. So you can see the temperature, the thermoconductivity is slightly lower than the reference one. So you go to the 3 dots, calibrate conductivity. I will get 598, it's close enough. You press OK. And then it's asking you to start a new sample and then continue with your measurement.
Okay.
You can do this directly, or if you want, you can wait 5 minutes. The reason of waiting 5 minutes is because you already increased the temperature of your fluid. Because if you see here, there is a temperature rise of 30 degrees. So the temperature is not 19.7, it's 22, 23.
Right.
So it's better to wait. Usually, especially if it's not inside the bath, it's good to wait
Hmm.
5-10 minutes to stabilize.
Okay.
And then you go again, new sample. Okay, you forgot to add the sample name and detect the power. When you're doing this, usually, depending how far away is the calibrated value from the previous measurement, this power will change. But
Okay.
again, you see that because the change in the thermal conductivity was not extreme, the power is close.
Okay.
And then you press save. If you want to say, I don't want to save the data. And then again, you need to wait some time. I will get the measurement right now. And then you will see that if the results should be the same or close enough to the measurement, to the calibration value for your fluid.
Okay.
There is I'm trying to think what else can cause issues with the sensor. Yeah, after the training, I would like to get the picture from the sensor, and
Yeah.
if you can try and get some measurements, and
Yes.
then send me in zip folder the XML files so I can see the problem. It will give me a better idea of what's happening in your system.
So if you'd like, I can share my
Sure.
screen and
Yes.
run through a sample.
Yeah. You can put your sensor inside, so everything will be.
Okay. Here's the version, by the way.
Okay, I think it's a bit older from the last one I had, but there are not much difference.
Okay. And here's the
Ooh.
setup we have for the sample.
Yeah.
And the sensor just goes inside that.
Okay. Do you have
So,
also, I don't know if you see, do you have these parts also?
oh, yes.
Okay.
Yeah.
It's better
Also,
if you want to keep the temperature stable and the sensor inside to use them.
All right. Then. You won't throw us. Really? You.
For right now, it's fine. Don't worry.
Okay. Sorry. Okay. How does it? So it goes. You pull it apart. Oh, you put the sensor in first. Sensor in first. Got it. Okay. The other way. The other way. The other way. Because then you can grab these things to pick it up.
Do you want me to show you?
No, I think I got it. It took me a second to figure out. Okay, there we go. Now it's in there. Okay, so I'm going to go to new sample. And you can see the power was very low. So should I say detect power here, or should I just try it at 200?
Yes.
Which one? Should I detect the power?
Detect the power.
All right. Okay, so yeah, it just goes
Try it while you're 200.
200. Okay.
Yeah.
Okay.
And save.
All right, and then I'm going to run single test.
Yeah. Okay, now the temperature is not stable, but we will have an idea of what's happening.
Okay. Interesting. All right.
Okay, now press on the measurement and then calibrate it to the peak
Okay.
0.6.
Definitely the first conversation about feeling is the one. Okay. Okay, so run a single test again? Or
No,
do I go
you
back to
go
new,
out,
new
you
sample?
sample, and now you will need to detect the power.
Okay, so that seems okay.
Yeah,
And then I'll run the test again.
yeah.
Next project for this one is to make it control temperature. Well, okay. Yeah, I think when I was running the samples before, the lid on the canister wasn't on, so I think maybe that was why they were so
What
fat.
a few things you need to check. First, you need to calibrate the sensor with distilled water. You can
Okay.
take the measurements always. Also, what you can do is when it's stable, you can run a schedule with 2, 3 measurements. So you will see also the repeatability. Make sure that when you, okay, I'm not sure if you can see the 100%. I will put the things again, so I will show you few stuff. So
Okay.
when you put, oops, here there isn't one loading.
Let me stop sharing.
You
so I-
borrowed this. So when and you can see this sensor I have is like a well-used sensor. So actually returned from a customer that they upgrade. So
Ah,
I know it was, and they had 3 of them. So make sure when you get the measurements, you see that this plate, like the lid, will not be touching the solder joint.
oh, okay. All right.
Okay, so it's now for you it will not be so big issue, but
Okay.
in case you put it in a temperature device, in that case maybe you will have issues. But the best is because then you have a connection between the lid, the cell, and the sensor.
Right. No,
Um,
I think I know exactly what was happening now. I think because we weren't using the lid, I think the solder joint was touching the edge of the canister and ruining the measurement.
Maybe it can be many reasons. Also, right now you are measuring distilled water. So after you do a proper weight more and do a proper calibration of the sensor and confirm
Right.
the repeatability of your measurements, then you can try to remeasure your tap water.
Okay.
If you see again changes in the thermal conductivity, but you will measure, you will not calibrate with the tap water because then
Right.
it's not pure. If you
Right.
see changes with the with the time of the thermoconductivity, it means that you have some minerals, then you cannot measure. In that case, if you want to protect your sensor, or in case you want to measure like nanofluids or something, what you can do is you can put something simple like the transparent nail polish on the solder joints and the temperature sensor to protect it, and then you will be able to measure.
Okay.
But it's small details, like especially if you have, if you're sure that the temperature of your fluid is stable, is very important for the activity. Yeah, and we suggest if you want just to see how is the measurement, you can use the front button. Because we are not suggesting, I'm not suggesting to use it for the calibration of the sensor because they are not using the same formula. They are not using the same algorithm. So the front button is using a constant power for all the fluid, but the detect power adjusts the power according to the fluid you are measuring. So the most accurate results are through the software. Anything else comes up? Or if you have any questions or you want to ask me something, I'm glad to help. This is part of my job, so yeah.
Okay, wonderful. Yeah, thank you. You've been very helpful.
Okay, I haven't done much. It was the fastest training.
Well, you fixed our problem, so that's good. I knew it was something stupid that I was doing, so.
No, it's not stupid. It's something that makes sense. And the most important thing is to, because if you're trying to calibrate with a fluid that is not standard, or if you are not, for example, if you were trying to calibrate the sensor using a very high or in your case, very low power, again, you will repeat the problem. But that's why I said, okay, now the power is asking is really high because of thermal conductivity. Let's try the standard. So it will be an average. And then we correct, because actually what is doing is a correction for the length of the wire. And now it's trying to correct again the value and be closer. And then you calibrate it again. So that was an advice for future use in case you need to replace the wire if something happens, because now the value was extreme high, but it was on. If anything comes up and you want any advice or any other fluid you want to measure, I'm glad to help.
Okay.
I'm here, so I have no problem.
Okay, thank you very much.
Thank you. Anything else I can answer?
No, I think we're happy.
Okay, thank you. Later today or tomorrow, I will send you the recording to keep it for future use. So, okay, thank you.
Perfect. Yeah, thank you.
Thank you. Bye.
Bye.